All right, we have some algebra issues here. It looked like what you tried to do was to say that since you're dividing by this thing, you're just going to multiply by the reciprocal. So you wrote something that looks like this: 1 cosine y, then you're multiplying by cosine y. Whoops, what did I just write there? Cosine y over 1. You wrote something like this. It's like, no, whoa, what's going on here? Um, if this 1 were not down in the denominator, so if the problem looked just like this, then what you have here is almost right. It should be multiplied by the whole thing because this is this whole numerator divided by that thing. Okay, so then that would be this, but then you'd have to distribute this in. Come on now, you'd have to distribute this into both of those, and you'd end up with a cosine y plus cosine squared y, right? You got to multiply by both. It didn't look like you're multiplying by both. But even then, this is not the right thing to do anyway because this plus 1 is here. That you're not just dividing by this thing, you're dividing by this plus 1, and you're going to have to add those two things together before you actually do the division. Okay, so a couple of ways that people approach this, um, and I'll show you both ways. One is that they turn this into a single fraction first. They get a common denominator and add that. So this thing is equal to, I'm going to just write the numerator down. I'm not doing anything with that yet. Right. The denominator here, I'm going to write this cosine y, sorry, this 1 as cosine y divided by cosine y. And then I've got the 1 over cosine y. All right, so I'm just trying to write this 1 with the same denominator that is. So multiply by cos y over cos y. So what I have now is I have a 1 plus cosine y on the top, and the denominator is now 1 plus cosine y divided by cosine y. So now I have that original numerator divided by this fraction. It's not a sum of two things anymore, it's just divided by this fraction. So now I really can say this is the numerator times the reciprocal of that fraction that I'm dividing by. Okay, and I have to do the whole thing times that. I mean, if you leave these parentheses out, then I can see people just multiplying this times the first thing, but it's the whole numerator divided by that fraction. So it's this whole, whoops, it's this whole thing here times the reciprocal. So, um, but then I notice that, hey, I'm multiplying by this and dividing by that, and those will cancel out, leaving me an answer just of cosine y. So that's one way to do it, where you combine this into a single fraction so that now you can multiply by the reciprocal, because it looks like that's what you wanted to do, but you got to have it as a single fraction first, not as a sum of two things. Now the other way that I see people do this is, so I'm going to write the problem down again. I've got 1 plus cosine y divided by 1 plus 1 over cosine y. Is they and they say I want to multiply by 1, and they go through and they look at each of the things that are being added in the numerator and added in the denominator, and everything that's a fraction, they say look for the denominators, and there's just one denominator here. It's cosine y. So I'm going to multiply the top by cosine y, and I'm going to multiply the bottom by cosine y. Now, the whole top, that is, there's a distributive property that says you're going to multiply both things in there. Okay. Now, I'm going to do the denominator first. So the cosine y times the 1 is cosine y, and the cosine y times 1 over cosine y, well, those cosines cancel out, leaving you just with a 1. In the numerator, I could do a distributive property too, except that I notice, oh, look, if I leave it unmultiplied, if I just leave it factored here, 1 plus cosine y times cosine y, then I recognize that the bottom looks just like that factor there. So that this and that are the same, and those will cancel out, leaving me with cosine y. Right? If you had multiplied this out, if you had said cosine, oops, if you had said cosine y plus cosine squared y, I mean, that would be okay. But then in order to cancel, you'd have to factor it back out again in order to cancel that. So two different ways. I know that as a student, this is the way that I would always do it. I felt very comfortable. It was big and messy, but I could just say, wait, I can add fractions, I can divide by fractions, and I would do it that way. This way just seemed kind of magical to me, but it's legit. This is the way I do it nowadays. I look for what the denominators are, and then I multiply top and bottom by those denominators. If I had more denominators, if I had something like, you know, a, if I had something like, let's see, a over 3 plus b over 7 divided by a over 5 plus b over 2, and I'd say I want to multiply top and bottom by 2, by 3, by 5, by 7. And so what happens is that when you multiply it, because there's a distributive property, right? You got to multiply it into everything here. So when you multiply this stuff times the first fraction, the 3's cancel out, and I've got 2 times 5 times 7 times a, right? The 3's cancel out. And then when you multiply it by the b over 7, the 7's cancel out, and I got 2 times 3 times 5 times b. And then in the bottom, the 5's cancel out, so 2 times 3 times 7 times a. And then here the 2's cancel out, so 3 times 5 times 7 times b, and whatever, that is. What's this? 35, 70a plus 30b over, what's that, 2142a plus 35 times 3, 705. Right? So, I mean, that's just a way of getting from a bigger 3 or 4 layer fraction down into a 2 layer fraction fairly quickly. Look at all those denominators and multiply top and bottom by both of them, and then distribute things in, and denominators cancel out. Right? Anyway, I hope that helps. Just be careful with your algebra. It's one of the biggest problems that people have is a little shaky algebra. So if you need help, keep asking, and we'll help you with your algebra too. So there you go.